students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as application of derivatives. Please take down the sum. Find the equation of the tangent to the curve. Find the equation of the tangent to the curve. Find the equation of the tangent to the curve. Y is equal to x square minus 5x. Y is equal to x square minus 5x at first part of the question, at the point where the curve meets x-axis. The point where the curve meets x-axis. Second part of the question, at the point where the abscissa is minus 2. At the point where the abscissa is minus 2. Now, equation of curve is given to you guys. I can say that first differentiate with respect to x. So I'll get dy dx of y is 2x minus 5. So therefore I can say dy by dx is 2x minus 5. But what is dy by dx? Dy by dx is nothing but the slope of the tangent, right? Therefore I can say that the slope of the curve, tangent to the curve, is nothing but 2x minus 5. Now the first part of the question, at the point where the curve meets x-axis, at the point where the curve meets x-axis, right? At the point where the curve meets x-axis. Now if the curve meets x-axis, y will be 0 at that point. On x-axis y will be 0. I can say it this way, on x-axis y is equal to 0. Once I come to know that y is 0, substitute the value of y is 0 in the equation of the curve. Substitute y is equal to 0 in equation of curve. So in that case I'll get 0 is x square minus 5x. 0 is equal to x minus 5. So I can say either x is equal to 0 or x is equal to 5, right? Once I have the two values of x, I can say therefore the curve meets the x-axis at the point 0, 0, y coordinate we had already assumed as 0, and 5, 0. So you now know the points where the curve meets x-axis. Now at 0, 0, what will the slope of the curve, the tangent to the curve be? At 0, 0, dy by dx will be nothing but 2 into 0 minus 5, so that will be minus 5. So I know slope, I know point, therefore I can find out the equation of tangent in point slope form. Equation of tangent in point slope form, y minus y1 is equal to mx minus x1. So y minus y1 0 is m minus 5, x minus x1 0. So y is equal to minus 5x, right? So I could say that 5x minus y is 0. That will be the equation of the tangent at the point where the curve meets the x-axis at 0, 0, right? Next, at the point plus 5, right? Next, the curve at the other point, at the point 5, 0, dy by dx is going to be 2 into 5 minus 5, 10 minus 5, that is 5. Therefore, I can say equation of tangent in point slope form y minus y1 is equal to mx minus x1, y minus y1 is equal to mx minus x1. So you will get y is equal to 5x minus 25. So 5x minus y minus 25 is 0 is the equation of the tangent to the curve. Fine. So those are the two equations of the tangent to the curve at the point where the curve meets the x-axis. Next, second part of the question. At the point where abscissa is minus 2. Now, I can say if abscissa is minus 2, that means the x coordinate of the given point is minus 2. I can say therefore x is minus 2. Substitute x is equal to minus 2 in the equation of the curve, right? Substitute x is equal to minus 2 in equation of curve. So in which case I will get equation of curve. So I will get y is equal to 4 minus plus 10. So you will get this point as say 14, right? Therefore, the given point is x is minus 2, y is 14. So the given point is minus 2 comma 14. Once I know the point, I can also find out the slope. I can say that dy by dx is 2x minus 5. So dy by dx is equal to 2x. X we found out as minus 2. So that's minus 4 minus 5, that's minus 9. Right? Once I know slope, I know point, I can find out the equation of tangent in point slope form. Which is y minus y1 is equal to mx minus x1. So in that case I can say y minus y1 14 is equal to mx minus x1 plus 2. So y minus 14 is minus 9x minus 18. So 9x plus y plus 4 is 0 is the equation of the tangent. Fine, do we get this in here? Next, let's move on to the next sum, guys. Take down another sum. A particle moves in a straight line. A particle moves in a straight line according to the law. According to the law, S is equal to 9t square minus t cube. S is equal to 9t square minus t cube. Find the displacement. Find the displacement when velocity is equal to 0. Find the displacement when velocity is equal to 0. Find the velocity when acceleration is 0. Find the velocity when acceleration is 0. Find the velocity when acceleration is 0. Fine. Now let's see this. First I'll say differentiate with respect to t. So I'll get d by dt of s is nothing but d by dt of 9t square minus t cube. So I'll get ds by dt is 9. T square can be written as 2t. T cube can be written as 3t square. So in that case this can be written as 18t minus 3t square. Right? Once you have this, next they have asked you to find out find the displacement when velocity is 0, but rate of change of displacement is nothing but velocity. That means I can therefore say that 18t minus 3t square should be equal to velocity, and velocity is given to you as 0. Therefore I can say 18t minus 3t square should be equal to 0, right? Once you have this, you can find the value of t from here. Take 3 common, so I'll get 6t minus t square is 0. 6t minus, here I could take t common, so in that case I'll get 6 minus t is 0. So either t is equal to 0 or t is equal to 6. T is equal to 0 is not possible because then displacement will not take place. T is equal to 0 is not possible, therefore t will be equal to 6. They have asked you to find out the displacement when velocity is 0. Velocity is 0 when time is 6. Therefore, displacement will be 18 into 6 minus 3 into 6 square minus 36, 50, 90, 108. Right? In that case, the displacement will be equal to 0. 6, this should be displacement. Velocity 0. Displacement is 9t square minus t cube. So 9t square, 6 square minus 6 cube. So this is 9. 36 minus, this should give you 216. So when you solve this, you should get this answer as 108. So the displacement is 108 when velocity is 0. Right? Once you have this, the next part of the question is find the acceleration when velocity is 0. No, find the velocity when acceleration is 0. Second part of the question, find the velocity when acceleration is 0. Now, velocity is nothing but change in displacement upon time, which we have already found out as 18t minus 3t square. Now, acceleration is nothing but rate of change of velocity, rate of change of 18t minus 3t square. So this is going to be 18 minus 60. Acceleration is going to be nothing but 18 minus 60. Once you have the value of acceleration, then I can say, but they have given you that acceleration is 0. That means I can say 18 minus 60 is 0. 18 is equal to 60. T is equal to 3. Now when t is equal to 3, what will the velocity be? Velocity we said is 18t minus 3t square. 18 into 3 minus 3 into 3 square. Right? That's 54 minus 27. 54 minus 27, that is going to be 27. Therefore, velocity is 27 meters per second if acceleration is 0. Right? And displacement is 108 meters when velocity is 0. Right? Next, take on another sum, guys. A square plate is contracting. A square plate is contracting at a uniform rate of 2 centimeters square per second. At 2 centimeters square per second. find the rate at which the perimeter is decreasing. Find the rate at which the perimeter is decreasing if the side of the square is 16 centimeters long. If the side of the square is 16 centimeters long. Let A, T and X be the area, perimeter and length of the side of the square. Right, therefore I can say that area is equal to x square. Area of a square is equal to x square. If I differentiate with respect to t, I get d by dt of A is nothing but 2x into dx by dt. Right? I'm using the formula u raised to n. Next, I can say perimeter of a square is 4x. If I differentiate with respect to t, I'll get dt by dt is nothing but 4 dx by dt. Right? Now, they've given you that area is contracting at the rate of 2 meters per second square. That means the change in area with time is 2 centimeters per second square, and since it is contracting, since the value of area is going on decreasing, therefore I'm going to indicate that with a negative sign. They have also given you that the length of the side is 16, right? Now if I substitute these two values in equation 1, we call this as equation 1 and equation 2. Substitute in equation 1. If I substitute in equation 1, I'll get minus 2 is 2 into 16 dx by dt is equal to 32 dx by dt. So in that case, I'll get minus 2 upon 32 is dx by dt, minus 1 upon 16 is dx by dt. Right? Once you have this, substitute dx by dt in equation 2. If I substitute dx by dt in equation 2, I'll get dt by dt is 4 into dx by dt minus 1 by 16, that's minus 1 by 4. Right? So rate of change of perimeter is going to be nothing but minus 1 by 4. Therefore I can say that perimeter decreases or contracts at a rate of 1 upon 4 centimeters per second. Right? Take out another sum, guys. Find the approximate value. Find the approximate value of cube root of 63. Find the approximate value of cube root of 63. Now, whatever value they ask you to find out, you will assume that as x. They've asked you to find out the value of 63. Leaving the function aside, they've asked you to find the value of 63. You will assume 63 to be x. So you will say let f of x be equal to cube root of x. Let us assume that f of x is equal to cube root of x. Now, differentiate with respect to x. So I'll get f bar of x is going to be nothing but d by dx of x raised to 1 by 3. D by dx of x raised to n is n x raised to n minus 1. So this is 1 by 3 x raised to minus 2 by 3. Again, I can say that f of x is cube root of x, in which case I can therefore say that f of x plus h, wherever there is x, substitute the value of x as x plus h. Wherever there is x, substitute the value of x as x plus h. So f of x plus h will be nothing but cube root of x plus h, right? Now 64, you want to find out cube root of 64. Find a number close to 64 whose cube root you can find out orally. 4, right? So you will say let x be equal to 4, 64. Cube root of 64 is 4, right? And h be equal to minus 1. In order to get 63, I can say 64 minus 1 is equal to 63. Now, this part is called as errors, right? And the formula for errors is f of x plus h is approximately equal to f of x plus h times f bar of x. F of x plus h is approximately equal to f of x plus h times f bar of x, right? In which case I can say this as f of x plus h is approximately equal to f of x plus h can be substituted as cube root of x plus h is approximately equal to f of x. Instead of f of x, I can write cube root of x plus h times f bar of x. F bar of x is nothing but 1 upon 3 x raised to minus 2 by 3. Right? Now substitute the value, so you will get cube root of 64 minus 1 is approximately equal to cube root of 64 h minus 1 upon 3, 64 raised to minus 2 by 3. I'm just substituting the value. So you can say that cube root of 63 is approximately equal to 4 minus 1 by 3, 4 raised to 3 raised to minus 2 by 3, right? 3 and 3 gets cancelled, so in that case you will get this approximately equal to 4 minus 1 by 3 into 4 raised to minus 2, approximately equal to 4, 1 by 3 into 1 by 16. Negative indice, bring it in the denominator, becomes positive indice. 4 square is 16. So this is approximately equal to 4 minus 1 upon 48. Right? So this is going to be approximately equal to, when you solve this, you will get this answer as 4 minus 0.0208. And your answer for cube root of 63 will be 3.9792. Fine, do we get this in here? Let's try another sum of this kind, guys. Find the approximate value of cos 59 degrees 50 minutes. Find the approximate value of cos 59 degrees 50 minutes, assuming 1 degree to be 0.0175 radians and sine 60 is equal to 0.8660. Same logic, whatever they ask you to find out, you assume that to be f of x. So you will say let f of x be equal to cos x. Therefore, f of x, f differentiate with respect to x. If I differentiate with respect to x, I will get f bar of x dy dx of cos x minus sin x. Right? I can say again, f of x is equal to cos x. Therefore, f of x plus h will be nothing but cos x plus h. Whenever there is x, I have substituted the value of x as x plus h. Now I can say that let x be equal to a value close to 59 degrees 15 minutes 60, right? Therefore I can say h is going to be nothing but minus 10 minutes, right? Now 10 minutes can be written as 10 upon 60 degrees. So this can be written as 1 degree divided by 6. I'm converting here from minutes to degree. To convert from minutes to degree, I'm dividing by 60. That gives me 1 degree divided by 6. But the value of 1 degree is given to you as 0.0175 radians divided by 6. Now use your formula. I can say f of x plus h is approximately equal to f of x plus h times f bar of x. F of x plus h can be substituted as cos x plus h is approximately equal to cos x plus h times f bar of x. F bar of x is nothing but minus sin x. Now this is going to be cos, substitute the value of x and h. If I substitute this, I'll get cos 60 degree minus 10 minutes is approximately equal to cos 60 h. H is minus 0.0175 divided by 6 into minus sin x. So this will become plus sin x. So this will be cos 59 degrees 50 minutes is approximately equal to cos 60 is 0.5 plus 0.0175 divided by 6 into sin x. Sin x is sin 60. Sin 60 value is given to you as 0.8660. You have all the values here. When you substitute them and solve them, you should get this answer as cos 59 degrees 50 minutes is approximately equal to 0.5025. Right? Let's see another sum of this kind, guys. Find the value of tan inverse of 0.99. Find the value of tan inverse of 0.99. Same method, let x be equal to tan inverse of x, differentiate with respect to x. So I'll get let f of x be equal to tan inverse of x. Therefore differentiate with respect to x. So I'll get f bar of x. dy dx of tan inverse of x is 1 upon 1 plus x square. I can say again f of x is tan inverse of x. Therefore I can say f of x plus h is nothing but tan inverse of x plus h. Right? Now take a value close to 0.99 whose tan inverse you know well. So I can say let x be equal to 1. Therefore I can say h will be equal to negative 0.01. Once you have this, you can use your formula. You can say that f of x plus h is approximately equal to f of x plus h times f bar of x. So in that case I can say tan inverse of x plus h is approximately equal to tan inverse of x plus h times 1 upon 1 plus x square. Substitute the values. Tan inverse of 1 minus 0.01 is approximately equal to tan inverse of 1 plus h. H we have taken as negative 0.01 upon 1 plus 1 square. Right? So you will get tan inverse of 0.99 is approximately equal to, we know that tan 45 is 1, so tan inverse of 1 will be 45. 45 can be written as pi by 4 radians minus 0.01 divided by 2, so which is approximately equal to 45 radians, pi radians by 4 minus 0.005. That will be your value of tan inverse of 0.009. Now here you could substitute the value if you want to get the precise value. Pi can be written as 3.142 divided by 4 minus 0.05. Simplify this further. If you simplify this further, you will get this answer as 0.7805 radians. 7805 radians. Right? Next, next sum. Another sum like this. Find the value of log 103 to the base 10. Find the value of log 103 to the base 10. Given that log e to the base 10 is 0.4343. Given that log e to the base 10 is 0.4343. Same method, let f of x be equal to log x to the base 10, differentiate with respect to x. So you will get f bar of x is d by dx of log x to the base 10. Now we do not have a formula for log x to the base 10. We have a formula for log x to the base e. So first thing I need to do is convert this. I'll use the change of base rule, so this can be written as d by dx of log x upon log 10. In both the cases the base will be e. Right? Now d by dx of log x is nothing but 1 upon x into log 10 to the base e. Right? Now if I want to change the position of the given number in the base, I have to reciprocate this. This can be written as log e to the base 10 upon x. If I want to convert log 10 to the base e to log e to the base 10, I have to reciprocate this. I'm reciprocating this so that I can interchange the number and the given base. Right? Once this is done, then I can say again f of x is log, yes, give me a minute please, log x to the base 10, yes, someone wanted to ask me something?
d by dx of log x to the base 10, what is the step after that, how did you get that step?
d by dx of log x to the base 10, I'm using change of base rule. Log x to the base 10 can be written as log x upon log 10. In both the cases the base is going to be e. That's the change of base rule. Right? Next. Let's come back here. Again f of x is log x to the base 10. So I can say f of x plus h is log x plus h to the base 10. Right? Now take a value close to 103 whose value you know well. Let x be equal to 100. Therefore h will be equal to 3. Use your formula f of x plus h. F of x plus h is approximately equal to f of x plus h times f bar of x. So in that case I can say that f of x plus h can be written as log x plus h to the base 10 is approximately equal to log x to the base 10 plus h. H we have taken as 3. F bar of x is log e to the base 10 upon x. Substitute the values, so you will get log 100 plus 3 to the base 10 is approximately equal to log 100 to the base 10 plus 3. Log e to the base 10 is given to you as 0.4343 upon x. X is 100. So you will get this as log 103 to the base 10 is approximately equal to This can be written as log 10 square to the base 10 plus 3 3 are 9, 4 3 are 12, 3 3 are 9, 4 3 are 12 upon 100. So this will be log 103 to the base 10 is approximately equal to 2 log 10 to the base 10 plus 0.013029. Log 10 to the base 10 is 1. So this will be nothing but 2 plus 0.013029. So which will approximately be equal to 2.013029. So log 103 to the base 10 will be 2.013029. Right? Now, we'll stop this here for the day. Thank you very much.